Calculus is an area of maths where we study two things, the derivative and integration. And we're going to start here with the derivative. What is it? Well, quite simply, it's the gradient or the rate of change of a function. Now the two things, gradient and rate of change, are the same thing. Up to now, you're familiar with the word gradient. You probably haven't come across rate of change, but I've introduced it because in later maths, that's what you're more likely to hear rather than the word gradient. And you have to recognize that when you have a question or a problem that talks about the rate, what they're actually talking about is the derivative. Now with a simple function, such as a straight line graph, it's fairly straightforward to calculate the gradient, and I'm sure you've all done this at various points. So you have actually been working out the derivative of a function without even realizing you're doing it. Let's just take this example here, and we have our straight line graph, and here's the equation of the function, and I should just put some numbers in to satisfy that. So if x1 is 1, y1 is 2, if x2 is 5, y2 is 4. So let's remind ourselves how we calculate the gradient. With our 2 points, we create our right-angled triangle, and gradient, the symbol is m, is our rise over run. Some of you will be familiar with that, which is our y2 minus y1. Our rise over our run is this length here, x2 minus x1. So in this case, if we substitute in our numbers, y2 is 4 minus 2, x2 minus x1 is 5 minus 1, we get 2 over 4, so we get a gradient equal to our half. That is our derivative. Now for a function that's not a straight line, it's not so straightforward. So let me just randomly draw another function. I'm not going to worry about what the equation is for it, but it is a function. Remember, the definition of a function is that for each x value there can only be one y value. Now if I'm to ask you to calculate the gradient of this, it's not so straightforward. It's nothing like for our straight line. And if we take this point here, that value of x there has a gradient which is that steepness. It's the gradient is the steepness of the tangent to the curve at that point. And that's a positive value. However, at this point on the curve, which is this x value here, the tangent to the curve is a negative value, so we've got a negative gradient. And if we're to choose this point here, that's the very top of the curve, so the tangent to the curve at that point is actually a horizontal line, so it has a gradient of 0. So for that x value, we've got a gradient of 0. This x value, it's negative. This x value here, it's a positive gradient. Everywhere along my graph is giving me a different value for the gradient, so it's much more complex to calculate. And the derivative, which is our gradient, depends on the value of x. So in the cases where it's not a straight line, where we have a curve in our function, the derivative itself is actually going to be a function of x. And we've got two methods of working it out. The first is we can find the derivative from first principles, and the second is we have a rule, a shorthand rule for finding the derivative. And there's 2 more videos, one on each of those to show you. So it's finding the derivative from first principles, and the second one is a rule for finding the derivative. But in every case, just remember that the derivative is either the gradient or the rate of change. They are one and the same.